Alrighty. Piecewise. What about them? Not much difference, really, except for one little wrinkle. So anyways, let's go ahead, direct substitution. Why? Because we can. We always try there. Start there first. So where do we plug -1 in? In which piece is x equal to -1? Yep, the first one. So we just plug it into direct substitution times the -1 minus 3, get -5. No big deal. What about at 4? As x approaches 4, what's the limit of this function? Again, which piece are we looking at? The parabola. So 4 squared minus 4, 12. No big deal kind of thing, right? Okay, what about this one? So now, as x approaches 2 from the left. Now, why is that important? Well, where is 2 from the left? Or the left side of 2, or negative side of 2? Less. The first piece. So we're going to use direct substitution in the first piece. So 2 times 2 minus 3. And we get 1. Now, before you go, wait, Mr. Kubitschek, it's not equal to. Exactly. So on the graph, since it would be not equal to, we would have an open circle at 2, 2, 1. Again, we're approaching, x approaches 2 from the left, so we're coming in from 2 from that side. The graph is getting closer and closer to the ordered pair, 2, 1. Never get there because it's an open circle. How about the right side limit? What happens on the right side, or the positive side of 2, or when x is just slightly greater than 2? That's this piece here. So what happens? So as we're approaching that graph from the right, and what do? Hey, still direct substitution. So 2 squared minus 4 equals 0. But wait, what's the difference on the or equal to? In terms of the limit, not a darn thing. In terms of the graph of the function, we'd have a closed circle here at 2, 0. But we're not graphing. We're trying to see just what the limit is. What's the behavior of the graph? On the left side of 2, on the right side of 2. Now, what about the limits? What happens then? If the left and right side are different, we don't have a limit at 2. It does not exist. Okay, so let's take a look at some of the other ones. Now with this function, same thing. Let's go ahead and take a look at it. As limit as x approaches 0 of f of x. Well, where's 0? Clearly, it's in the second piece. X at 0 is greater than -1, so we could use direct substitution of 0 squared minus 8, and we get it. Cubed minus 8, and we get it to be -8. No problem. What about the second piece? As x approaches -1, or it goes to -1 of the function. What's that limit? Well, yes, x equals -1 is up here, but that's equals. That would be f of -1, not the function, or not the limit. It would be the function. We don't want that, but so where does it approach? Well, we got 2 different possibilities. The only way to check is to plug in both of them in. What I mean by is the limit as x, don't know why we wrote it up there. Does the limit as x approaches -1 from the left side of the function, is that equal to the limit as x approaches -1 from the right? So do these 2 sides approach the same number? In other words, I'm going to use the term connected. Even if it's connected with an open circle, that's fine. I don't care. But are they connected, or are they one to another? Is there a jump in between from one y value to the next y value, to the next function value? Again, what do? Direct substitution. So square root of 5 minus 3 times the -1 So we get the square root of 8 or 2 square roots of 2. Actually, square root of 8 would be okay in this case because that's not our final answer. What happens at -1 in the second piece? Again, so are they to the right where x is greater, or to the right positive side of -1? So -1 cubed minus 8 gives us -9. Are those two equal? Nope. So this limit does not exist. The only time you need to check the two-sided limits is when something like this is happening. When your value, what you're approaching, is one of those times where you're changing pieces from one side to the next. If not, just use direct substitution. That's the only time you have to guarantee it. And when I say only, I'm talking like 95% of the time. It's the only time we introduce or need the one-sided limits is when we're approaching the function, or on the function, we have two different definitions for them from the left and right side. So we have to check that. Okay, that's piecewise. We'll pick up the infinity ones on part 4.